Hey, welcome back to Math with Patrick. Today's August 20th, and we're solving problem number 232 from this Daily Epsilon calendar. And the answer today should be 20 because the answers usually match the day's date. So since today's the 20th, we should expect an answer of 20 for today. How many four-digit numbers ABCD satisfy the following conditions? And I'm assuming here A, B, C, D, each of these are the digits. So we're not considering this as being multiplied. It just means like this A right here is the number for the thousands digit. B is how many hundreds we have. C is how many tens, and D is how many ones. Anyways, A is equal to B. So these two digits are the same. D is the smallest digit, so this one has to be less than these ones. And then C is the average of A and D. Okay, that at least kind of bodes well for these two conditions, because if D is the smallest, then the average of A and D should be, bigger than the smallest digit. So I don't see any contradictions here, but that's good. So we at least have some numbers to work with. And let's just kind of see what happens here. I'm noticing that like C and D are kind of dependent on what we choose for A and B, right? Because once we choose a value for A, we get a value for B. Then we know the limitations on how big D is able to be. And then we can find the average to get C. So I think it all really depends on what we choose for A and B first. And since it's a four-digit number, I don't think A, and therefore B, is allowed to be 0. Because say, for example, we have A equals 0, and then B is the same as A, and then we pick just some other numbers for C and D. Not only are we breaking the rule of this condition right here, we're also breaking the rule of what a four-digit number even means. Like 0 thousands, 0 hundreds, plus 49, that's just the number 49. And this is a two-digit number, not a four-digit number. And so A shouldn't be 0 for at least two reasons. And therefore, I'm going to consider maybe 9 through 1 as our possible digits for A. So we'll do 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then since B is the same as A, I know that essentially I could just copy the same list again. Oh, that's supposed to be a 7. But I'm not going to, just to save space. I know that whatever A is, B will be it as well. And then D is the smallest digit. So I actually know if A is 9, D can't be 8, because then once I take the average of A and D, I'll get 8.5, and 8.5 isn't a digit. I need this average to be a whole number. Oh, and in fact, if I choose any even number here, like if I choose 9 and 6, and I average that, that's 7.5. And so in the case that A is 9, D can't be even, or else we don't get a digit for our average. So maybe D is going to be like 7, or 5, or 3, or 1. Sorry, wait. Yeah, that would work. Because then C would be the average of these numbers. So maybe if D is 7 and A is 9, C could be 8. If A is 9 and D is 5, then C could be 7. And so it looks like for any odd number D, I can find a reasonable average and set that to be the digit C. So I don't think I actually really need to write that, because once I decide what A and D are, and I make sure that I have a reasonable average, then what I'm seeing here is 4 different four-digit numbers based on these conditions right here. Like for example, this first 7 kind of to me is representing the number 9987, right? Because these are copies of each other, and 9 and 7 average to 8. 7 indeed is still the lowest number. And then so if I looked at this 1, that would be put a 1 in that spot for the digit D. And then I could find the average of 9 and 1, and I would get 5. And so this number right here is the four-digit number that we're actually talking about, but I'm just kind of representing counting it up by just this one right here, just to save some space. And so we can move on to this digit. When a is equal to 8, b is automatically equal to 8. And I think if we average two numbers and get another whole number, 8 and the other number, they both have to be even now. And so d could not be 7, because then we would get a non-whole number average. So that means d could be 6 or 4 or 2. And I think 0 is allowed, right? Because d is the smallest digit. Cool, 0 counts as a digit. And then the average of 8 and 0 is 4. So this 0 right here represents the number 8,840. And that's a 4-digit number. Okay. And so I think this is all the logic we really needed to go through. Now it's pretty easy to just kind of fill out the rest for the rest of the digits for A. Because then, D has to be an odd number, D has to be less. So I'm only allowed to pick 5, 3, or 1. And then when A is 6, I have to pick even numbers. So D could be 4, 2, or 0. And then I have 3, 1, 2, 0. And then I think just the 1 and just the 0 here, right? Because that 1, again, represents the number 3,300. And then 1 in the 1's place, so a 2 for the average of 3 and 1. So that's what this number, or that's what this 1 represents, is that number. And then this 0 right here represents the number 2,210. And then finally, once we reach A equals 1, I think we actually don't have any numbers out of this. Because if A is 1, then B is 1. And if D is the smallest digit, then it has to be 0. But I can't average 1 and 0 and get a whole number digit for C. And so I don't have any valid 4-digit numbers out of that condition. So here are all of our numbers. We have 8 4-digit numbers represented here. We have 6 right here. There's 4, and then there's 2. And counting them all up, I see 10 and another 10. And so overall, we do get 20 4-digit numbers that satisfy these 4 conditions. So I think that's it. I think we're all done. We found all 20, and I don't really feel like writing them all out. So I'll see you for tomorrow's problem. And of course, thanks for coming along and solving this one with me. So before we go, you can say hello and goodbye to Quill, and we'll see you tomorrow. Bye.